You see before you the Molecules tab of an IP-GeoScape, this one for the target CDK2. The principal feature of the Molecules tab is the landscape. Each marker in the landscape is an exemplified compound extracted from CDK2 IP publications or a compound extracted from the scientific literature as part of the chemical database. They are colored by assignee, and the different shapes within the same color are different patent families from the same assignee. White colored markers represent compounds extracted from the scientific literature. The examples are clustered together based upon similarity using our proprietary molecular numericalization scheme, and the clusters are grouped on the same basis. You will also note that there are unoccupied spaces, represented by what we call empty clusters. I'll speak more about those in discussing the Clusters tab. When you see markers of different colors in the same cluster, it means more than one assignee are working on similar molecules. You can clearly see how similar these structures are to each other and understand why they were clustered together. As you can see, the landscape is completely interactive. There is a set of filters on the right that allow you to mine the landscape. The IP-GeoScape is data agnostic. Any data connected to the assignee, the patent family, or the compound can be used to filter. One interesting way to use the filters is to view only the compounds from one company. You can select them from the assignee list in the assignee group. In this case, we will select Nerviano as our example. You can see they occupy a number of different clusters spread out over the landscape. You can then further filter to see how Nerviano's chemistry evolved over time by using the priority slider under the patent group. If you slide over to the left to show only their first priority year, you see that Nerviano had one patent family with a priority year of 2001. You can see those structures here. Left-clicking on the background will allow you to clear any selections you have made. As we expand the range of the different chemical series they tried, you can see they added another in 2002, and a third in 2006. Take a look at this particular chemotype. Then we expand the range to their final series in 2007, which is a close neighbor. And if you look at the two series, you can see that what they did in 2007 was cyclize the link between the heterocycles from their third chemotype. I do also want to point out that there are filters connected to the compounds. These include basic Lipinski rules and topological polar surface area. You can reset any of the filters by clicking on this circular arrow. Substructure searching is possible and allows you to understand what scaffolds have been used and whether there are ways around current IP. If you do a substructure search using a diaminothiazole core, you find that there are 710 molecules, 656 from the patents, 54 from the literature, from 3 different assignees that have this core, and they're all grouped together in a similar area. Additionally, all 710 of those have a substituent on the 2 amino position. If we were trying to see how many have a substituent at the 4 amino position, we would find that there are 0. This is important information for both avoiding the IP of others and potentially understanding the structure-activity relationships for a chemical series. Thank you.